Okay, I can see that people are still joining, so we are going to wait for 2 more minutes before we start. Am I audible for everybody?
Yes, ma'am.
Okay, okay, nice. Let's just wait because I can see people are joining, and then I'll start the class. Okay, I think we can start the class. So let me just turn on my Okay, I'll share my screen. Okay, so so hi everyone. Welcome to week 3 of these problem solving sessions. So first of all, due to some personal things, I was not able to take yesterday's class. So thank you for all joining at the correct time. I mean the rescheduled time and taking time on Sunday to join. So if anyone is joining for the first time, my name is Zinia. I am a PhD student and Prime Minister's Research Fellow at ISC, and my research is primarily in astrophysics. And as I've mentioned in the classes, Python programming is something that I use every day in my research. So, what you need to understand is that programming is a tool which we can use. It's a skill set that we can use and we can apply to different areas of life. And in today's world, whatever field you're in, programming will be there playing a factor in any some aspect of it. And as I said in the early classes, Python is a really good language to start as your first programming language because Python has a relatively easier syntax or a more straightforward syntax, but that has its advantages and disadvantages, as I said. So yeah, there are many things to talk about, but main thing is that Python programming, as I said, it's a skill set that you're developing and that you should apply to whatever your field is. So coming to these sessions are basically for us to interact and some live sessions for us to interact. So here basically we'll be solving some problems together in the class. So I'll give you some time first to solve the problems and then we'll try to discuss the solutions. Also, we'll do some programming because as I've said on all the classes, the only way to learn programming is by doing it yourself. You cannot learn programming by reading books. You cannot learn programming by watching other people's programs or reading other people's programs. How much ever you think you understand the logic of a program, until you sit down and try to write it down yourself, you will not have many doubts, will then only start coming up. So it's important that you do enough practice as part of this course and as part of learning programming. And this once a week session is for that, basically for you to practice. That's how I see it. Okay, so sincerely, if you do the programs here, it will be good for you. Apart from that, yeah, we'll also discuss. So this week's session will be about the week three materials. Well, first discuss a little bit about the week three material, and then we'll do some problems. Is there a question? Okay, if there's not a question, I'm going to mute you. Uh, Guys, if you don't have a question, please keep yourself muted because otherwise there is this echo or background noise and it's very disturbing for everybody. Okay, but if you have a question, please feel free to unmute and interrupt me at any point of time during the class. Otherwise, you can also put your queries or comments in the chat box. I'll be looking at the chat box on the side time to time so that I can see if anyone has any queries. Okay, so as I said, this session is about the week three material. And before I start the class, the part that people are very worried about every time. So this is my website. Here I've maintained all the links where you can find not only the recordings of all the sessions which are being uploaded on YouTube, but also the slides of the sessions and the programs which we discuss in the class that also I've been uploading on the Google Drive. Okay, I think these links have been shared to you by the NPTEL team. But in case you want one place to have all the links, I would suggest just bookmark this page. I've put it in the chat box. If you click the link, as you can see, you'll find my course page. If you just go here, this is the YouTube playlist where the 2 weeks of video has already been uploaded. Apart from that, you can find the slides of the sessions here. So week two, if you see, I've uploaded the slides. I've also uploaded all the programs that we have discussed. Okay. So try to do this. And again, as I'm saying, whenever you try to do a program, even though I'm giving you the Python code, always try to write your own program and you can use these solutions as a guide in case you get stuck. But I will strongly suggest that you do it yourself because finally, if you just are looking at someone's program and copying it, only you are the loser. Okay. So this is about all the housekeeping, about where to find the slides, where to find the thing, and if you have any questions, you can mail me. So I think few of you had mailed me regarding some assignment discrepancy, like when you're submitting the assignment, some issues coming or something. So I was a bit busy this week, so I couldn't respond personally. But I'm just going to say this out right now. I'm an external person who is here to solve problems for you. So I'm not in charge of assignment or correction, exam, pattern of exam, all these kinds of things. Okay, those things are not up to me. So, if you find any issue, the best place to resolve this is there is a team that's dedicated for designing assignment, explaining assignments, correcting assignment, designing exam, etc. That's I'm not involved in that. If you find that you're writing correct answer and getting some issue or something, please bring this up to the team in either through mail or you have that discussion forum. It's the best place to do it. For me, I would say that you can mail me, but most I won't be able to help with these kinds of things. I can help you with some conceptual understanding. I can help you if you want extra resources to understand something. I can also even help you that if you say, for example, ma'am, I didn't understand recursion, for example, the one of the topics we're discussing today. If you says to me like, I didn't understand recursion, can you explain it in detail in your class? Then I will make sure to put a section of recursion fully in my class. So that kind of thing you can ask me on mail and I will be able to help you. Okay, I hope this is clear. It's just because I am not in charge of assignment or correcting or that side of things. So I really won't be able to help you if you ask questions like about the assignment or the exam. Okay, this is the idea. So if you find that people are not responding or something, you can ask me, we can find. Okay, someone had asked about the link, but someone has already sent it. Yeah, just bookmark this page. This page has the meeting link, it has this, it has the slides, and it has the YouTube playlist. Everything is already in one page, so that's why I made this page. So please just keep this page saved. Then you won't have, because every class I think once every 20 minutes or so, there'll be one question about the recording and the slides. So don't forget, I am making these sessions for you. So we won't leave you without giving you the slides or the recordings. So don't worry about it. Okay. So great. Okay. So this is about yeah, housekeeping. Yeah, so you can mail me. My email ID is in every week's presentation. So if you have any conceptual questions, and again, as I said, these are live sessions, right? The you have recorded lectures, but here is a session where you can interact with me. So as I said, if you want some particular topic to be covered in a particular class, please mail me, and I can include that in the thing. Other than that, if you have any queries, you can mail me. But when it comes to assignments, etc., I might not be correct person to help. Also, whenever you get feedback on something, try to read it. You might be able to understand where you went wrong as well. These kinds of things, especially when you're entering some value and it comes out that it's not correct, there may be spaces. All these small things can also mess things up. So try doing some troubleshooting on your own as well. Okay. Fine. So let's go to today's class. Yeah, sorting will be one of the things we discuss. So someone has already mentioned. So that's a good enough segue for us to go to today's actual material. So just to say, okay, sorry, this is, yeah, sorry, I didn't update the recap. So this week you saw lists, sorting, recursion. Okay, these are the things that I'm going to be discussing today. Sorry, I think this is week three. Yeah, week three. Yeah, I was just confused because the recap was different. Did I? Yeah, okay, cool. So, okay, let's go through these concepts one by one. So, as I said previously, there are two parts to writing a program, right? One part is figuring out the algorithm, or what is a problem statement and how to best tackle that problem statement, right? So that was your algorithm. So if you think back to the very first class, you have this idea of finding the greatest common factor, and you found that there are many different ways to do it. There are many algorithms to achieve the same problem, right? The second part is like the language in which you write. Not only am I talking about Python, but I mean like you need to use variables, you need to use certain data types to get across the problem. You need to use lists, for example, which we'll be looking at today, and so on. So the idea is that you need to know what you need to know the flow of the program, which is basically what are the different steps you require. Then you need all the data types and variables that can handle the different steps of the programs. There are many things. There's loops, there's if else statements, there's data types. So we looked at some of them last week. So now this week, you saw some very important algorithms which are related to sorting numbers, and you also saw this general kind of idea of recursion, which is a way in which we can use an algorithm in a more efficient way when it comes to certain programs which have this capacity. Okay, so this is the idea of today as recap, and yeah, again, these are things you already saw in the class. So we are going to just go through these once more before we go to solving the problems. Okay, so in every class, I'm going to be showing this, starting with this, because this is very important. This is as important as learning programming, as important as learning how to write a program, is learning how to write a good program. Okay, and what do I mean by a good program? So you can always just write a program with whatever name you want, it's up to you, right? But there are some, and you can just write program in 3 4 lines and finish it, and that's a very good, that may be doing the job. But a good program is such that you can hand this program off to someone else, and they will have very minimal questions about. As long as they are a person who understands basics of programming, they should be able to immediately identify your program, and that is a hallmark of a good program. So for this, do some basic things like choosing meaningful variable and function names. Use comments. So comments, as you will see if you see my programs which I shared with you, are when you put a hash and you write something next to the program. This doesn't affect the program at all. This is just some notes for yourself. It doesn't affect the programming or anything. It's just for explanation of certain steps that you require, right? Use indentation. Indentation is very important. Indentation is basically the spacing, and If your program is sufficiently complicated, you should also create readme files or something so that you have a document which explains what exactly the program is and what are the different steps you will do. You won't believe, but right now you will write programs and you'll think that I don't need to write comments for this program. It's very obvious to me that what this is doing. It's very obvious that this is using Euclid's algorithm or something like that. 1 year later, if you are like, okay, let me take my programs from that Python course, you will not be able to remember. It's natural, right? We are all dealing with many things. So we won't remember all the different exercises we did, especially in a course like this where you'll be doing many programs per week. Oh, you should be doing, by the way, you should be, whenever you encounter a program in the class or in this class or in any of the problem solving classes, you should be doing it yourself also. So when you have this huge number of programs, we might forget all the steps in all of them, right? So always use the fact that you can write comments, and good programmer always keeps very neat, clean, files. Don't give random ABCD 1 2 3 4 names. Keep proper names for your files, keep proper names for your functions and variables, and use comments. Okay. Okay. So first of all, you saw about lists this week. So we have already kind of dealt with lists over the last 2 weeks. Even if you don't know all the properties of lists, you have used them, right? Like in the GCF program, you did this version of the very first brute force way in which you can calculate the greatest common factor is that you are taking the factors of the first number, storing in a list, taking the factors of the second number and storing in a list. So yeah, you saw, ultimately you saw that that was not necessary, but yeah, there was a way in which you used lists. Similarly, last week also, I think in some of the example cases, definitely we used many lists for we solved couple of programs. What are the programs exactly? So there was this program of reversing and adding primes. Yeah, those programs you used lists, right? But this is just basically the proper definition. So list can be, it's like a container of different elements. So there are different elements in the same variable name. And you know that if you want to access a list, we have to use 0 1 2 etc. How do you so you can see that the elements can be numbers, it can be words or strings, it can be anything. Okay. So the point is that list items are ordered, they're changeable and allow duplicate values. So why changeable is important? You saw, for example, last week that something like a string, you cannot change part of a string, right? That's not allowed in Python. We have to either change the entire string, or we can't we yeah we have to either change the entire string or we can't change it at all. So lists are not like that. I can change only the first element of the I can change only the last element of the list if I want. So again, one important thing when it comes to list is that apple is the zeroth element. So my list of 0 gives apple, my list of 1 gives banana, and so on. So the indexing starts from 0. That is a very important thing to keep in mind. Lists have their own operations, like you can do list dot remove of x, just removes the element from the list. Append adds an index of x return. So if I give list dot index of apple, that will give me 0, for example. List dot reverses the order of the list, and so on. So what is an easy way to access the last element of the list? Anyone?
Length
We
of the
simply
list minus
did the
one.
-1.
Yeah, exactly. So if I use -1, that helps me to access the last element of the list. -2 accesses the second last element, and so on. So basically, if I use index starting from 0 1 2 3, I am reading the list in the forward direction. But if I want to read the list in reverse, I can use -1, -2, -3, etc. Okay. So yeah, these are, and with lists, they are very powerful things. Like you can splice a list, you can take a portion of a list, you can take from the second element to the last element, first element to the second element, and so on. And this is very important. Closely related to list is the range. Like range is, as you saw, range returns a list of elements up to n minus 1. It's like range of 5 will give you 0 1 2 3 4, right? And you can always change around with range. And lists and range are used a lot when we have to do repeated actions or store certain things, because these are very easily manipulated things. Okay, fine. So this is about lists. So so let's look at a very simple Yeah, okay. So list dot remove to, so yeah, this will just remove the elements, I think. Can you give like, yeah. Yeah, yeah. So second, starting from the second element, which is actually the third element, because 0, 1, 2, it'll remove everything. Okay. That one which that person has shared in the chat. Okay. So now, what was I saying? Now we have seen a little bit about lists. Let's try to do one thing and let's look at one of the very simple operations that you can, simple to describe operations you can do on a list, which is a sorting, right? Suppose I have a list of all numbers now. I ask you to sort it in either ascending or descending order, right? Then what you will find is that even though this is a very simple program, this is something that we all start off doing in our first or second standard, right? Arranging elements in ascending order or descending order. But actually, in computer science, you'll find that there are many different ways to do it. So here we'll look at three different ways of doing the algorithm, and you yourself will be able to see how efficiency matters. So as I showed you, or as I told you in the very first class, there is a reason that we are using computer, right? We're using computer because computer is able to do something that is very difficult for us, or it's able to do something that takes a lot of time for us. So if I have a computer want printing 100 lines for me, I shouldn't be sitting and writing 100 print statements. I've used this example too many times, but this is a best example of it, right? I can of course sit and write 100 print statements, but what's the difference between writing 100 print statements and myself taking a paper and writing 100 times? There's no difference, right? I should use the I should take advantage of the fact that the computer is a machine that can be very efficient. Similarly, in the print statement case, it's very obvious. It's like, this is definitely, it can be very easily. In certain cases it may not be as obvious. So let's look at sorting and let's look at a few algorithms, and you can decide how efficient each of them are when it comes to handling this issue of arranging elements in ascending or descending order. So in the following, I will describe how to do it for ascending order, and I will share you the programs of ascending order also. But I want you guys to, as an exercise, also figure out how to do this for descending order. Ascending order means we are arranging from smallest to largest. Descending order means we are starting with largest and going to smallest. So I'll be showing you all the programs and logic for the ascending order. But after the class, please try to work out the logic. It'll be the same idea, but certain things will have to be changed so that we can have the descending order program also. Okay, so that is up to you. So anyway, these are the three sorting algorithms we will discuss today. There's bubble sort, selection sort, and insertion sort. Okay, let's start with bubble sort. So bubble sort is the simplest thing, simplest way to describe it at least. So, okay, sorry. So here essentially what happens is that you at you take, so here you have an initial array which is given of what is it, like 5 elements, right? And you can see that they are all jumbled, and our goal is that we want to arrange this in ascending order, so it'll be 3, 4, 5, 6, 8. Okay, now what happens is, sorry. So what happens is that in bubble sort, you essentially you bubble up the largest element at a time. Okay, that's why it's called bubble sort, because it's like the biggest element bubbles up to the top essentially. So what it'll do is it'll first compare the first two elements. So it compares 5 and 3. If they are not in the correct order, which means that the bigger element is before the smaller element, it swaps them. If it is in the correct order, it doesn't do anything. Okay, so here you can see that actually when it comes to 5 and 3, it's in the wrong order, right? 5 should come after 3 if you're looking for ascending order. So it swaps them. We discussed how to do swapping in the last class. So you can just put, you just check the element I and then you check the element I plus 1. If they are not in the correct order, swap them. So now they are swapped, and now the array is from 53846, the array is 35846. Now it will check the next two elements. So it will check 5 and 8. Now 5 and 8, are they in the correct order or in the wrong order? This 5, 8, is it in the correct order or wrong order?
Correct order, ma'am.
Correct order, right? Yeah, because 5 is smaller, 8 is bigger, so it's in the correct order. So I do not swap. Okay, because it's already in the correct order, I don't swap. Go to the next. So now the array is not changed. It's still 3, 5, 8, 4, 6. Okay. So now I check for the next two elements, which is 8 and 4. Okay. So in 8 and 4, they are in the wrong order again. So we have to again swap it. So now it is 3, 5, 4, 8, 6. Exactly, in correct order, and we have to swap it. Now 3, 5, 4, 8, 6. It will check the next two elements, which is 8 and 6. Again, they are wrong. So it swaps. Now this is the array I get after I reach the end. So it's 3, 5, 4, 6, 8. Is this all? Is it in the correct order now?
No,
5 and
ma'am.
4 need to be swapped, ma'am.
Exactly. So in this particular case, 5 and 4 need to be swapped, but in general, doing it once throughout will not be the solution, right? We have to keep repeating this. Now, I'm at the end of the array. So now what I have to do is I have to go back to step 1. Now I have to check the first two elements. Now the first two elements are 3 and 5. I will not swap it. Then it will check 5 and 4. I will swap it. Then I will check 5 and 6. I won't swap it. 6 and 8, I won't swap it. So you have to keep doing this procedure until no more swaps are required. So you'll keep track of the number of swaps. And if no swaps are there in a full cycle, then that means that the array is completely sorted. So you have to keep repeating this process. So you have to check each element, and then when you reach the end of the array, go back, check again. Okay, so even after you fully sorted it, you have to anyway go back once and check again that no more swaps are required. So, what will be the worst kind of list to give to this kind of algorithm, or in general in a sorting algorithm? Okay, yeah, wait for a second, I'll give an recap. What will be the worst kind of list to give to this algorithm? If I'm trying to sort a
Totally
list.
descending
A
order.
descending ordered algorithm.
Totally
Like,
descending, right? Exactly. So suppose I have something like whatever 86421. Okay, 86421. Then first it will swap 8 and 6. Then it will swap this. So every element it will swap. Then again it will go back and swap everything. Right? Because every time it has to. So the point is that the way why this is called bubble sort is, if you notice, what's actually happening is 8 has bubbled up to the last position. Now in the next position, if you take a fully descending array, you will see exactly what's happening. Every time the largest element reaches the end, and then the next second largest element reaches the second end. That's how a bubble sort works. So that's why it's called a bubble sort. Okay. So I'll show you the program in action. Before that, someone just joined. Okay. So not much. We just discussed about lists and their functions, and then we're discussing sorting. This is the first kind of sorting that we have. Sorting means arranging in ascending or descending order. So here we are talking about ascending order. I'll be showing you the logic and the programs for all ascending order sorting. I want you guys to, in your free time, figure all of this out for descending. Okay. It's not that drastically different, but you can imagine that, here I'm looking for the larger element, there I'll have to look for the smaller element, and so on. So you'll have to change the algorithm a little bit. Okay. So try it yourself, try understand the fully the ascending order program, then try to write the descending order program without looking at the ascending order or any of the nodes. That will make you understand both of them. Okay. So the point is that here in a bubble sort, what happens is successive elements of the array. So the two neighbors of the array are compared, and if they are not in the correct order, they are swapped. If they are in the correct order, they are not swapped. So for example, when I'll first check the first two elements, right? 5 and 3. 5 and 3 are not in the correct order, so they are swapped. Then I'm checking the next two elements, 5 and 8. They are in the correct order, so I don't swap, and so on and so forth. And this process has to be kept repeating until there are no more swaps which are required to keep it in the correct order. So this is a bubble sort. So let's try to look at the program for it. Wait, sorry. Yeah. Okay. So, okay. So let me just, first of all, this is the array I have given 23, 10, 2, and 1. So after sorting, so you can see that this is a completely descending array, right? So let's play this. I mean, run this code, and you can see that it sorts it to 1, 2, 10, 23. So let's try to look at the code, right? This is the function which defines bubble sort, right? And then here you have the length of the array to be some n. So now you have a nested for loop, okay? A nested loop, by nested loop, what I mean is there is a loop within a loop, okay? So here you can see that we have a for loop first to look through all the elements of the array. Okay, so for I in range n means first it will take the first element. Then it has to compare for j in range 0, comma n minus I minus 1. So here what you will do is you are checking the adjacent elements. You can see that I'm checking for j and j plus 1. So this is basically to run the loop n times, because as I said, in the worst case scenario when it is descending order, essentially what is happening in bubble sort is the largest element is always reaching the end. So right, suppose it's descending order, like this case, then what will happen is I need one pass to make 23 reach the end. Then I need another pass to make 10 reach the end. I need another pass to make 2 reach wherever it should be. And I should need another pass to make 1 reach where it is. Okay. So just think of it as a worst case scenario where all of them are in the wrong position all the time. Okay. In that case, I need as many passes as there are elements in the array, right? Because each of the element has to reach the correct position. So this for loop is basically for repeating as many times as there are elements in the array so that all of them finally reach the correct position. This j loop is for comparing the adjacent elements, because not only there are two processes happening, right? There are two loops happening. One loop is for me to just compare elements among each other, compare neighbors, pairs of elements. The other loop is to keep repeating this whole process. So one is this process itself. The second loop is I'm repeating the whole process as well. Okay. So that is what is being done here, which is that you can see that array of j, if array of j is greater than array of j plus 1, you can see that we have to run this n times, because in the worst case scenario, it will run n times, right? So here you can see that if array of j is whatever, suppose j is 0, then j plus 1 will be 1, and it will compare 0 and 1. And if they are in the wrong order, which means greater than, if the jth element is bigger than the j plus 1th element, then they are in the wrong order, so they are swapped. And this is one way to do swapping. Already we have discussed, this is a very Python way of doing swapping. This doesn't work in other languages, but already we have discussed many ways to do swapping. So this is just a code for swap. Maybe I'll just mention it. So here you can do whatever you want. You can use a temporary variable. You can use whatever you want. So this is just a code for swapping. Okay. And then that's it. So this will run n times so that all the elements reach the correct position. So this is the idea of bubble sorting. Okay. Cool. So this is the first kind of sort that you saw. As you saw that even if we get through the correct list, we still run it as many times as there are elements. So you can do certain things, like you can keep a count of how many swaps are there and you can break the loop or something. But in the most general form, what do? You keep swapping things until you reach the thing. So every time you're trying to get the biggest element or the certain element in the correct position. That's why you have to run it n times as many elements are there. Okay, so that's why when you get a completely descending loop, descending array, it's not a very good thing. Once, can you explain the range of j in bubble sort? Okay, sure. Uh, okay. Where's my VSC? Uh, okay. So here you can see that j goes from 0 to n minus I minus 1. Okay, so let's try to understand. So as I said, the way to think of bubble sort is, in the first pass, the largest element reaches the end. In the second pass, the second largest element reaches the second last position, and so on. So once, for example, in this case, what has happened? 8 has reached the correct position, right? After that, I don't need to check for 8 again, right? I only need to check 3, 5, 4, 6. So every time I check from 0 to n minus I minus 1. So n minus I means I'm checking for, once the first element is done, then I'm checking for n minus 1 elements. Then I'm checking for n minus 2 and so on. This minus 1 is because of range. Okay. So now basically what happens is that suppose I finish the first pass, right? suppose I finish the first part. So n is 0. So now let's look back at this example. 8 has reached. So I'm only going to check 3, 5, and then 5, 4, and then 5, 4, 6. Okay. So I have 1, 2, 3, right? So what is the original n is 4. The length of n is 4. Right. Sorry. I'm checking for I minus 1, n minus I minus 1, because I'm only checking for the previous, those kinds of cases. That's what's happening essentially. Okay. Because every time I'm checking until the leaving the last element. So when it becomes n, I mean, it won't become n. When it becomes n minus 1, then this, basically becomes 0. So yeah, at the end, last thing, you don't have to sort it. It's just one element. Okay. Okay, fine. I hope you all understood the bubble sort program. So we'll go to the next program. Great. Okay. So the next type of sorting is called selection sort. Okay. So just, yeah. So selection sort is the one. So let me. Uh-huh. So selection sort is basically like you are at every time you are selecting the minimum element. Okay, here you are like swapping every time, right? You are swapping every time. Like the moment you see that 3 and 5 are in the wrong position, you swap them. Whereas here, you keep track of which is the minimum element. You keep calculating which is the minimum element, and then you put it in the correct position. So you're not doing the swap until the end. So you can see that here what's happening is, yeah, it is comparing pairs of elements. Like in bubble sort, it is checking for 20 and 12, which is smaller, 12 is smaller. So first iteration, it finds that 12 is the smallest element, right? So it saves that minimum is 12, for example. Then it will check if any element is less than 12. Then it immediately finds that 10 is smaller. So now the smallest element is 10. Okay, it checks 10 and 15. 10 and 15, which is smaller, 10 is only smaller. So still the smallest element is 10. Then it will compare what is left now. 10 and 2 has to be compared. Then we find that 2 is actually the smallest element. Then what happens is you swap 2 to the beginning of the array. Okay, so it might look very similar to bubble sort, but there is a difference, right? In bubble sort, the moment we found that something is in the wrong order, we kept swapping, right? You're going through the array, you're swapping, 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 or not swapping and doing, and then again you're going through the array. Here what you're doing is, you're you're going through the full array and you're finding which is the smallest number. Then you're only doing one swap. You're taking that smallest number and putting it at the beginning of the array. Then what will you do with that? Will the array be sorted? No. Then you'll go through the rest of the array, find the second smallest number, put it at the correct position, find the third smallest number, put it at the correct position, and so on. So this is selection sort, because every time you are selecting what is the smallest element, and then you are putting it in the nth position. Okay, so this is the difference between bubble sort and selection sort. Do you guys understand any doubts in this idea before I go to the program? Okay, good.
Once again explain the selection sort now.
Okay, fine. So in bubble sort, what you did is that you have, suppose you had 5, 4, whatever, 3, 5, 3, 8, 4, 6. In this case, maybe I'll explain the same array, then it'll be easier. So in this case, what I did is, first I check pairs of elements. I keep checking pairs of elements and over again, right? So first I checked 5 and 3. Because 5 and 3 are not in the correct order, we swapped them. Then we looked at 5 and 8. They are in the correct order, don't do any action. Then we checked 8 and 4, we swapped them. So basically what I'm trying to say is, the moment you find that something is in the wrong order, you're immediately taking some action. You're swapping them, right? In selection sort, what you do is, you go through the full array and you find the smallest element. So what it will do is, it will compare. Obviously, to find the smallest element, we again have to compare all the pairs of the elements, similar to bubble sort. But here we will not do the swapping. So here, for example, first I compare 20 and 12, which is the smallest element, 12 so far. Then I compare 12 and 10, which is the smallest element, it's 10. Now 10 has to be the smallest element. Then I compare 10 and 15. In 10 and 15, which is the smallest element, it's 10. Then I compare. Now I only need to compare with 10. I only need to compare with the smallest element, right? So now I compare 10 and 2. That is only element left to compare. We find that 2 is actually the smallest element. So every time I'm going through the full list and I'm trying to find which is the minimum or the smallest number which is there. Then I only do one swap, which is that I take the minimum position and I change it to the first position. Then what will I do? With that, is it over? No. Then I again repeat the process and then I find the second smallest element. In this case, that will be 10. So excluding 2, which is the smallest element, 10. Then 10 has to be placed here. Then again, I'll repeat until I get 12, 15, and so on. Is selection sorting? Okay, there's a question in the chat. Let me show it here. No, I mean, what do you mean? Is it sorting only in terms of the smallest number? Okay, you can do it in terms of largest number also if you want. You change the largest number to the end. I think both will be equivalent. I think this is what you're saying, right? I can also identify the largest number and place it at the end of the array. That's what you're saying, I think. Yeah, I think those will be equivalent, right? So that's why I said that once you get this get understand these different algorithms, not exactly what you're saying, but somewhat related, is try to write these programs which I've given you, try to write them for descending order. And it's quite easy. You can easily do it. But what I would say is rather than change the program I've given you, try to sit and write it from scratch, then you'll understand better. But yeah, this could be done in terms of largest also. That the ways that you're selecting, you can think of it as selecting the smallest or the largest number at a time, right? So first I select the smallest number of the array, I place it wherever it is. Then I select the second smallest number, place it wherever it is, and so on and so on. That's how it goes. So let's look at how this looks in Python. So, okay, is there a question?
Ma'am, can we do increasing and decreasing selection sorting simultaneously?
What does that mean? Increasing and decreasing. What do you mean by simultaneous increasing, decreasing sort?
Just like we have sorted minimum number to the right.
Mm-hmm.
Can we do maximum and minimum simultaneously? Like
Okay,
minimum to the right and
you're saying minimum to the left. Yeah, that's probably possible. But then you have to think about what happens when you reach the last. It should be okay. When you reach the last element, what will you do? You have to think about. But I think other than that, then at that, okay, the last element, the minimum and the maximum will be the same number because there's only one number, right? So yeah, that should be possible. You can try writing it down and see how it works. Okay, great. So that's a good question. That's an exercise, again, an additional exercise for you guys. So let's try to see this, how the selection sort looks like in Python. So we are again passing an array and we are passing some size of the array. And yeah, here I've passed the size as a argument, but not necessary to do that. So basically, if for a S in range, so again it's going through the whole thing, and then you take the minimum index to be S, and then here this is for doing n passes example. So again, every time the worst case scenario we have to think about, which is that all n numbers are in the wrong position. So we have to take n passes to sort it out properly. So we assume that the first element is the smallest element, and then if at all we ever find any minimum element, we change it to that index. Okay, and then you swap it. That's all that's happening. So yeah, this is basically swapping. So swapping here again is not the pairs that are kept on swapping in the bubble sort. Here we are simply swapping the minimum index to the first position, the second minimum to the second position, and so on. Okay, that is what I mean by swapping. So here you can see that if we assume, for example, that the first element is the smallest, like in this chart, I've assumed first that 20 is the smallest. I found 12 is smaller, so I've then replaced the minimum value to be 12. whatever. Here in terms of the index is now I. If I find any number that's even smaller than that, I have to update I to be the index of that number. So this is the idea. Okay. So if I run this, it looks similar to before, but you can basically see that sorting array in ascending order is 1, 2, 6, 7. Okay. And then array we originally had was 7, 2, 1, 6. Okay. So this is about sorting. And, your friends have come up with different ways in which we can change this program. For example, I can make this into a maximum program. I can also make this into, in which case the way in which I go through the array has to be a little different. Here, you're starting with 0 going to S, but if it's maximum, then I have to do it in a different way. Similarly, if I do minimum and maximum at the same time, the problem is that the indexing has to be done in such a way that maybe there'll be two loops. So maybe it's equivalent to, whatever we do by that time, minimum itself may do the job. But you can always, try it out yourself and see how it goes, right? You can always write the last element in terms of something, and you can do it. You just have to figure out how to index it so that the last element goes to the last position and the first position goes to the first. So what am I saying? The maximum element goes to the last position and the minimum element goes first position at the same time. That if you figure out, it should be doable. So yeah, take it as an exercise and try it out. So this is the first two sorting. What didn't you get? What is the doubt? What is the exact doubt? Did you not understand the sort at all? Okay, so just think of, okay, fine. So I'm going to repeat this one more time and then maybe we can move on because we need to do the problems also. So basically what you're doing is, okay, I'll explain with the program if that's easier. Okay. So we are going to identify every time the smallest element and then put it at the correct position. Okay. So suppose I have 5, 4, 3, 2, 1. First, I will take 1 and put it in the first position. Second time, I will find 1 is already in the correct position. So I only need to look at 5, 4, 3, 2. What is the smallest element? X. Sorry, is there a question? If there's no question, I'm muting. I don't think there's a question, so I've muted you because there's some disturbance. Right. So first I take 5, 4, 3, 2, 1. Identify that 1 is the smallest element, keep it in the correct position. Then from 5, 4, 3, 2, I identify which is the smallest element 2 and keep it in the correct position. 5, 4, 3, 3 is the correct element, put it in the third position, and so on. This is the idea, okay? So I have to go through n times and find the nth smallest element. The first time I find the smallest, second time I find the second smallest, etc. So in bubble sort, I was actually swapping as I went along. Here I'm not swapping, I'm only doing one swap. Right, I only swap the smallest element to the correct position, second smallest to the correct position, and so on. In bubble sort, in one iteration itself, I had so many swaps, and then again I'm going through the array and doing so many swaps. Okay, this is the difference. You can see that here I go through the entire array. Okay, so first, this is for S elements in the array. So first I have to find the first smallest, second smallest up to S the smallest element, okay, whatever it is. So how do you identify the minimum element of an array? There are some built-in things, but if I want to brute force it, I assume first that the first element is the minimum element. And whenever I find any element of the array or the list which is smaller than that element, I update the index of the minimum element to be that element. So if we talk in terms of this, I first assume, without knowing anything, before starting, I assume that 20 is the smallest element. Then I go through the list. I compare if any number is smaller than 20. So first I compare 20 and 12. I immediately find that 12 is smaller. So okay, 20 is not no longer my smallest element, 12 is my smallest element. So you can see that the minimum value index is now updated, right? Now I go to, now I see if there's any number smaller than 12. So I compare 12 with the next element 10. 10 is much smaller. So we now update the minimum value to be 12, 10. I mean, the minimum value to be 10, the index is at 2. Now I compare 10 and 15. In 10 and 15, 10 is still smaller, so I don't have to update the minimum value. It's still at 10 only. Then if I compare 10 and 2, I find that 2 is smaller, so the minimum value is at index 4. Now, because I know that where the minimum element is, that is 2, I have to swap its position with whatever is in the first position, because 2 should actually be at the beginning of the list. So I do one swap at the end of this process between 2 and 20. There's only one swap. Then what do? I repeat this whole process, but this time I'm trying to find the second smallest element. 2 is already in the correct position. I don't need to consider it. So I'll find that 10 is the next number. I'll swap it to the correct position. That's what's happening. Okay, is this understandable now?
Yes, ma'am.
Okay, good. So let's go to the final thing. I wanted to do more things. Okay, it's fine. So let's go to this now. This is insertion sort. Okay. In insertion sort, what you're trying to do is that you are going to be building a sub array. Okay. Basically, you're going to be building a sorted sub array. So you can see it in this, right? In the first pass, okay, only one element. In the second pass, I just sort this element, right? 1 and 23. The third pass, this looks very similar to bubble sort, but please see the differences. In the third pass, I insert to 10 into the current. Is there a question? Okay. So in the third, what I'm doing here is that I'm building the array element by element and I'm inserting the element in the correct position. So here you can see that 1 has to be inserted here. 10 has to be inserted between 1 and 23. So I'm building the array one by one. Here 5 has to be inserted. Is there a question? Hello?
I
Okay.
think he is experiencing some network issues, ma'am.
Okay. If you are having a question, please put it in the chat because I am not able to understand what you're saying. So let me just go back. Okay, so here, yeah, so here, what was I saying? So here, what you do is you insert, you're building the array. Okay, you're building the array element by element and you're inserting the element. Every time you add a new element, you insert it in the correct position. So you start with an array of one element, which is 23. You build it to 123. Then you build it to 110, 23. So when I'm adding 10 to the array, I'm inserting it in the correct position. Now 5, I have to insert between 1 and 10. 2, I have to insert between 1 and 5. So it's not really a bubble sort because bubble sort means I would have first swapped 5 with 23, then we would have swapped 5 with 10 in the next iteration, right? Instead of that, I'm just putting 5 in its correct position in one shot. Okay, this is what is called an insertion sort. So this will become more clear if we look at, again, if we look at the program. So let me take the program. So this is insertion sort. Okay. So now, hmm, you can see that it sorts the list. Let's look at what's happening. Okay. So we first have an outer loop, as in all the cases, we have an outer loop to just go through, the list again and again. Okay. So you take an element of the list to be some I, okay, which is just going through the list. So in the first pass, it will be the first element. And then move elements of list 1 from 0 to I minus 1. So that means that, again, as I said, you're building a sub list, okay? In the first case, you have only one element in your list. In the second case, you have two elements in your list. So you have to think of it like you have your whole list, and in insertion sort, in every pass, you're creating a smaller list within the list, and that list you're sorting. Okay, so here first I have 23, then I have 1 and 23, 110, whatever is shown in green. Okay, until the smaller list has all the elements of the bigger list. That's how you think of insertion sort. You're inserting elements to the smaller list until it contains all the elements of your original list. This is how you think about insertion sorting. So now what you do is yeah, so j is equal to I minus 1, while j is greater than equal to 0, a is less than list 1 of j. So basically, while your j is greater than equal to 0, because basically, this is an index, it cannot be negative, and you're checking for all the elements below that element, basically. Okay. So list 1 of blah 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 is equal to this, and then you're subtracting. So you're basically trying to insert it in the correct position, because you're checking where is it smaller. Okay. And then the moment it becomes bigger than it, you get the element, you get the what is it called, the function, the index of, just when the element becomes bigger, that point you get the element to be inserted there. Okay. So basically what you're doing is, you start off with a sub list, and then you check where your element a. So for example, in this case, let's take this example, right? I have my sub list 123. I want to insert 10. So what I'll do is, I'll check where 10 is less than, I mean, the last position where 10 is less than some element of this list. So that's 23. So that's why I'm inserting it between. That's exactly what's happening here, which is that I'm comparing with a sublist which contains all the elements before it. Okay, so for example, when I consider 5, I have to consider the list of elements before it, 1, 10, and 23. And then I find the last position where it is smaller than an element, and I insert it there. That's what's happening here. Okay, any questions?
Could you show the PPT once again? So here on the fourth pass, if we select the number 5, it will compare with the previous elements and also the next element. Am I correct, ma'am?
No, so 5 is comparing with 1, 10, 23. It's like
Which
as
is
if
which is already in
sorted.
the okay, okay.
So basically, you are building a smaller list, and that list is sorted. And then whenever you add, it's like you're adding 5, and you're adding 5 in the correct position, so it remains sorted. That's what you're doing. So you're inserting it, right? That's why it's
So
called
so
insertion
this is the
sorting.
main difference between insertion and the bubble.
Yeah, in bubble, what you're doing is, bubble, you would have compared 5 and 23, you would have swapped it. Then in the next pass completely, you would have compared 5 and 10 and swapped it, right?
Yeah, in the bubble set, we will actually compare the previously sorted elements on the next
Yeah,
iteration of the outer for loop. But
yeah,
here,
exactly.
it is changing. Okay, ma'am.
That's, yeah, that is one thing. And the other thing is, in bubble sort, you will change it only one at a time. Like if I have 10, 23, 5, first it will compare 10 and 23, then it compare 23 and 5. So it will take two steps to reach it, right? Whereas here we are just putting it in one step. That's what I'm trying to say.
Okay, ma'am. Okay, ma'am.
Okay, cool. So in insertion sort, okay, so the three sorts are bubble sort. Bubble sort is where the largest element bubbles to the top by comparing and every time, and you do it 10 times. Then there's selection sort, where you select the smallest element, put it in the correct position, whatever it is. The third one is insertion sort, where we create a smaller list and we keep inserting elements at the right position so that we ultimately get a sorted list. So this is the idea behind um, insertion sort and this. Okay, code, once you can give a quick overview. Can we perform insertion sort in arrays? Yeah, I mean, what are we doing right now? We are doing it in an array, right? List array, it's like you can use it interchangeably, in the sense that, yeah, array is like a collection. Okay, list can be of strings or whatever. Arrays can also be of that. I don't know. I think list and array can be used interchangeably, but I'm not a
Similar to
programmer.
similar to array, lists are also in the continuous memory location.
Yeah, yeah. I don't know those technical, I don't know the exact technicalities, but arrays in Python are basically going by lists. List is the data type that we call in Python, but array is the general concept of just having, as he says, a continuous memory location and having some data stored together in a under a certain single variable name. So if you ask, can we do sorting on arrays? We are doing sorting on arrays. That's the answer. So code, can you give a quick overview? This is the code. Okay. So imagine or remember that what we are trying to do is we are making a smaller list inside our bigger list and we are adding elements to it. So this green part is your smaller list. The moment your smaller list has contained all the elements of your original list, this loop stops. So I have to run it for as many elements are there in the list. That's exactly what this first loop is for. Okay, then what you're doing is you're taking this element A. Okay, suppose I take the, just imagine that A is 10. Then I'm checking in this loop where is the last position where A is less than list. Okay, so maybe it's better to take say 5. Okay, so yeah, 5 is less than, it'll first check 5 is less than 23, it is satisfied. Then I'll check is 5 less than 10 also, yes, it is satisfied. Then I'll check 5 is less than 1, no, that's not satisfied. So the last element where 5 is less than is 10, right? So it will insert it before 10. Do you understand? Now this is what this while loop is doing. I'll maybe write it here. Last before is smaller. Okay, so then it just decreases because every time it's checking until the beginning of the list. And then it inserts it at that correct position. So this is called insertion sorting. Okay. So let's okay, it's 4 o'clock. I wanted to, the last concept we have before we go to the programs is recursion. Okay, so recursion is basically, you can see from this meme, basically when we define a function based on itself, and we saw an example of this in the very first class, right? So something like your factorial program is going to be a recursive program, because to calculate 5 factorial, for example, you need to calculate 4. So does everyone know what a factorial is? That's a very famous recursive program,
So
but
5
math.
factorial is nothing but 5 into 4 into 3 into 2 into 1.
Exactly. So a factorial is a mathematical concept. Okay. It's basically n factorial will be the product of all the numbers up to n. So if I tell you to calculate 3 factorial, that's 1 into 2 into 3, which is 6. Okay. 4 factorial is 1 to 2 into 3 into 4, and so on. So if I want to calculate, for example, 10 factorial, I can, it will, I can always write n factorial as n minus 1 factorial into n, right? If you think about 5 factorial, for example, 1 into 2 into 3 into 4 into 5, that is basically 1 into 2 into 3 into 4, which is 4 factorial into 5, right? So I can write as 5 into 4 factorial. Then I can write 4 factorial as 3 factorial into 4, etc., etc. So basically, to calculate factorial of n, I calculate factorial of n minus 1, which goes to n minus 2, and so on. So this is the idea of recursion, right? For calculating factorial of n, I will call factorial of n minus 1, and so on. One very important thing when it comes to recursion, and we look at it shortly, is that you should always have a base case. Okay, otherwise it will go on forever, right? Usually in factorial, the base case is that 1 factorial is equal to 1. So you have to stop it there. Otherwise, it will keep going, right? It will be like 1 factorial means I have to calculate 0, 0 factorial means I have to calculate minus 1. It will keep on subtracting and going somewhere. So you have to stop it at some point. Okay. So whenever you define a recursive function means I just keep on calling the. Okay, a base case means that there is a stopping point basically. For factorial, that stopping point will be basically 1 factorial is 1 or 0 factorial is 0. Because suppose I have 3 factorial. I say that, okay, I define my factorial by saying that a factorial of n is equal to n minus n into factorial of n minus 1. So the computer will say, okay, I have to calculate 3 factorial. That means I will calculate 3 into 2 factorial. That means I will calculate 3 into 2 into 1 factorial, which means I'll calculate 3 into 2 into 1 into 0 factorial. And if I had not defined 0 factorial to be 1, what will happen is it will keep going. It will say, okay, 0 factorial means 0 into minus 1 factorial, minus 2 factorial, keep going, right, till minus infinity. So it will become an infinite loop. So there is no meaning of having a negative factorial anyway. So you need to always have a stopping point whenever you define recursion, because recursion means it'll keep calling itself. So you should have a stopping point, and that stopping point, the example I gave is factorial, but there are many different ways of doing recursion. I mean, many different programs where this can be applicable, but the main thing is you should have a stopping point, which is called the base case. Okay, so this is the idea behind recursion. Let's go through the programs now. Let me see. Now it's 4. So I have some questions and then I have programs. So let's do one thing. We'll try to solve the questions, and then programs will try to do at least one or two, and then the others I'll share the solutions with you. Okay. So as usual, I think there are no questions with recursion. Even if there are, doing the exercises will help you better, because it's very theoretical to explain like this. It's better to just write a program and understand, right? So let me show you the programs. So let me show you these questions, which will be mostly like MCQ and other things. And let's try to do these fast. Like, you can answer in the chat as usual. And then we'll try to do one or two programs like that you write also, so that it will be. And then if we don't have time for anything, don't worry. I will be sharing the slides. I will be sharing the programs with you. So you can take your time and look at it also. Okay. So here's the first question. This is a list based question. Okay. What is the output of this piece of code? Okay, so here is a piece of code. Now, if L is equal to 1, 2, 3, 4, so this is about slicing. Okay, this is probably you know already. L of 1, 2, 3 will take the first element to the second element. Basically, 3 is not included. So yeah, and this is about list concatenation. If I have 1, 2, 3 plus 4, 5, 6, then P plus Q will just be the list 1, 2, 3, 4, 5, 6. Okay, so these are just list manipulation. So just try to work out what will this code give me for as an output. So you can put your options in the answers in the chat. Slides and solutions I'll share at the end, but the links are being shared with you every week by the NPTEL team, so you can find it. Other than that, I have a website where I maintain all the links. I'll discuss that at the end. Or if someone can find the link and share it also, it's fine.
Babu, Babu, Babu.
Okay. I can see that there's one answer, which is C. Anyone else?
आया पानी पिया
Okay, one more person says C. Okay, C. I'll give a few more minutes in case, 2 more minutes in case people are working it out. Okay, good. C. Okay, good. I can see that the majority of, all of you are saying C. So let's go to the answer. I think, yeah. Okay, thanks everyone. I'm going to the answer. The answer is actually C. Oh, okay. So one person had given A. I think you got it slightly wrong. Just check.
झुक के रहना पड़ेगा मेरे आगे
Kindly mute Sindhu, ma'am. He is the one
Yeah,
always disturbing the class
I had
in
muted,
every
but
classes, ma'am.
they are kind of unmuting themselves. Okay, I have muted now. Okay, okay, fine. So as I was saying, the answer is C. So can anyone who got the answer tell me what is this list actually doing? Or what is this list? What is this program actually doing? Yeah, it is also doing a type of sorting, right? Here we are doing a sorting in terms of we are getting basically the ascending order, right? So this is basically insertion sort, but in a different way, if you think about it. Yeah, I'm explaining. So basically, this is the list that you originally have, which is 90, 47, 8, 18, 10, 7. You start by taking S, which is another list, to have just one element. Okay. You go through the entire list, right? Go through all the elements. And then this is basically insertion sort, but it's written in a different way than the insertion sort I showed you. So remember, there are many different programming is somewhere where you can use your full creativity. So you should take
एक
advantage
बार
of that.
देश का पूरे हिंदुस्तान में हर घर में पैसों के
I'm going to disable mic for this person because if you have any question, You can please write in the chat because that is an issue. Okay, so as I was saying, you can see that there's a flag which says true. And essentially what happens is you keep going for if L of I is less than S of J, so you're checking with the elements of I. Okay, so you're not, you start with the first element, right? So it starts with 1. So first it checks for 47. Let's just try it once. So 47 is less than 90. So that means that it will take all the elements which are before index J. This is the element which contains this one element, and this is the elements in S starting from J. Okay, so in this case, S doesn't have anything, right? S just has one element. So before, after, and all is not going to play a role. Whereas here we just have the new element, right? Which is the 47, which we are trying to add to S. So essentially, what is it doing? It's taking 47 and it's identifying where should I insert it in S. S is your sorted array. So that's why you have this before, new, and after. Okay. Then uh, whenever L whenever this condition is false, it breaks, right? It breaks out of this if loop, if this if condition, because essentially we don't have any more elements which are smaller than it. That's what happens. So that means that suppose here 90 is the biggest element, so there's no such question. Yeah, but okay, if in first condition it becomes false, it'll break out of the loop, but the for loop is still going. Sorry, not the loop. It'll break out of this if, but the for loop is still there, right? This one is to add any large elements at the end, but here the largest element is in the beginning itself. So yeah, I hope you understand. It's basically the insertion sort, but written in a different way. Okay, I think it's fine. Let's go to the next question. Okay, next question is this. Considering following code snippet, what does it do? A, B, C, or D? This is not as difficult as the previous program, I think. So, okay, I can see one person says C and one person says A. Others? Okay, I can see that there are multiple answers, A, B, and C. Okay, C, A, B. There's no majority yet. So I'll give you some more time to work this out. Seems to be between B is the majority now, or A and B. Hmm. For me, it looks like B is the majority answer. I'll give one more minute in case any other answers are there. Okay, now some people are saying C. Guys, please don't do this. Keep your mics muted if you don't have anything to say related to the class. Okay. Okay, I see some more people saying C. Any other answers? Yeah, keep your mics muted, by the way, not only for me, but because these sessions are recorded and put on YouTube. So, I would say that be careful in general if you're going to share your mic. Okay, so, right. Others, let me check the answer. Okay, I can see that it seems to be like B is leading with C very close back. So let's go to the answer. The answer is actually C. So I didn't think that you guys will be so confused with this because this is simpler than the previous program. But essentially, what's happening here? We're defining a list elements, which is an empty list. Then n is the count of the elements, right? Here we are asking enter the number of elements. So it's actually taking the count of the elements followed by a loop which takes the same number of elements as input. So first it'll take element 1. Suppose I entered that there are 5 elements, then it'll take element 1, then element 2, 3, 4, 5, appending them to a list. So append means adding to a list, then prints the list of elements. So that's what it's doing. So this is the count, this is where the elements are being entered, and this is the printing of the list. Okay. I don't think there should be any questions in this. Maybe you guys got a little confused with the wording, but yeah, any doubts?
No, ma'am.
I think this. Okay, good. So let's go to the next question. Yeah, be very careful. I don't know if these kinds of questions will come, but basically, in general, be careful when you read a question and options and other things. Okay. Okay. How many passes does bubble sort make through an array in the worst case scenario for sorting n elements? Yes, this is related to programming assignment of third. I mean, it's not exact question, but it's basically related to concepts of third week. Okay, so the answer is, I think most of you had answered. Oh, sorry, I switched to the answer. Oops, sorry, if you guys were answering, but the answer is B. N minus 1. It's not n squared and it is not 2n. Basically, it will go through the list n minus 1 times, right? Because in the last pass, the only one element is left. As I said, biggest element has to reach the end. That is the idea. Okay. So the answer is B. Okay. Select the correct statements among the following in the presence of duplicate elements, binary search. Okay, this is about binary search. This is a multiple select question, so there can be multiple correct answers. Please check and answer. You guys did binary search, right? Did you guys do binary search? Yeah, okay. Okay, some people are answering D, A, and B, I can see. Okay, you guys have not done the binary search. Okay, then we can skip this question. The answer is there in the slide, but maybe we can go to the next question. Okay, fine. The answer for that question was basically, I'm just skipping it in case people don't understand binary search. I think I thought this was a sorting question and included it. But basically, binary search is where you find you're trying to search for an element in a list. Suppose I have 1, 2, 3, 4, 5. You're trying to find what's the position of 3, for example. So binary search kind of can be yeah, it divides the list into two, and then it searches the left list, searches the right list, it searches a sorted list for an element. Okay, so yeah, it's about duplicate elements in binary search. Those of you who know it, you know that when you split the list and if there are two elements with the same, it might be that you one of the occurrences of the element but not the other, and that's what this question is about. Okay, so let's go to this next question because I want to get to the programs. That's why I'm a little bit rushing. If you guys want me to explain something in more detail, you can stop me. Okay, so consider the following snippet of code. L is a non-empty list of positive integers. Which of the following statements is correct about the recursive function of L? So why is this recursive? Because I am defining a function L, a func of L, and to define that function, I'm actually calling the function itself, right? Within the definition itself, I'm calling the function. So please answer in the chat. Okay, one person says B. Okay, there are two people saying C. I think it is a tie between B and C, or yeah. Again, look at the code carefully. I think slightly now there are more people saying B than C. I'll give one more minute so that you guys can figure it out. Okay, seems okay. One person has said D actually, but others are saying B or C. Looks like B is slightly more people are saying B than C. So shall we go to the answer, or I think we can go to the answer. Uh, Again, be very careful with these kinds of questions. The answer is B. Okay. So the important thing is, well, it's not A. So don't worry about it. There are only one correct answer here. So here basically you're passing a list and you're adding one for every even element that is there. You're not adding the element itself. This is not saying L of X or whatever it is. You're adding one, which means you're counting the number of even elements. You're not taking the sum of the even elements. There is a difference, right? If I give you a list and it's 1, 2, 3, 4, 5, the number of even elements is 2, but the sum of the elements is 6 because 2 plus 4 is 6. Okay, so here I'm adding 1 for every even element which is present in the list L. Okay, is this clear to everyone? So those of you who said B were correct. And why is recursion used here? Because while looking at L, I'm first looking at from the first element onwards, then the second element onwards, and so on. So I keep on reducing the number of the list. That's what's happening here. Okay, is this fine for everybody? Okay, I'm assuming you don't have any questions. Good. So, okay, this is the next question. It looks very similar. Okay, so now knowing what you know about that question, please read properly and answer the question. Okay, and read the, even though the program looks similar, it is not the same. So read the program carefully and answer the question. Okay, someone says A, someone says B, someone says A. Read the code very carefully. It's not the same. A, D, another person says A, D. Okay, I can see. Okay, now I see that three people have said D. Okay, now all of you are saying D. Okay, still one person saying A, D. Okay, so it seems like it's between D and A at this point. So let's go to the solution. Here the solution is actually D. Okay, because here the solution is actually D, because here you can see what's the difference between this code and this code. Here I'm adding 1 every time I get an even element. Here, first of all, I'm checking for an odd element. So I know it's something to do with odd elements, but I'm not adding 1. I am adding that element itself. I'm every time checking for the last element if it's odd or not, and then I'm adding that element itself. So here I'm actually getting the sum of the elements and not the number of elements. Is this clear? So that is the difference between those two programs, right? With one small few changes, I made it from program which looks at the total number of elements to program which look at the sum of the elements. Okay? Is this clear to everybody? Okay, good. So now we can go to the programming. Oh, wait, is there more? Okay, this is the last question. Good. So, okay, so before we go to programming, the last question, which I explained during the theory, what is the purpose of the base case and recursive functions? So I explained this in the class. This is just a theory question, so you should answer immediately. Okay, good. Many of you have said C immediately. You're paying attention. Exactly. If I don't have a base case, then the recursion will go on forever. It will keep going to calling itself for an infinite loop, and that is not correct. So, for example, here my recursive function, you can see that the moment I keep reducing the list, and you have this empty list. Okay, I saw your question about assignment. I'll come to it, but let me just come to the programming first. So, okay, so now let's do some programs. We have half an hour. I think I have 3 programs. Let's try to do at least 2. Okay, and whatever we don't cover, I'll share it with you. Okay, so here's the first program. Write a function contracting of L, which takes input of integer, a list of integer L, and returns true if the absolute difference between each pair of elements strictly decreases. Okay, so there are a few things going on. We have a list of integers, and then we are taking the absolute difference between a pair of elements. Okay, so for example, 9 minus 2 is 7, 2 minus 7 is or 7 minus 2, whichever way you want the absolute difference, right? 7 minus 2 is 5, 7 minus 3 is 4, and 3 minus 1 is 2. So that means we have 7, 5, 4, 2. So that is decreasing, right? 7, 5, 4, 2 is a decreasing thing. So that's why it returns true. Similarly, here we have 10, 7, 4, 1. So 10 minus 7 is 3. 7 minus 4 is also 3. 4 minus 1 is also 3. It is not strictly decreasing. The difference between all the elements is the same. So that's why it returns false. Okay. So these are the example cases. So 3 minus 2 is 5. 7 minus 2 is 3. Sorry, 7 minus 3 is 4. 7 minus 2 is 5. Etc. Adjacent means nearby. So 9 and 2 are adjacent elements. 2 and 7 are adjacent. So that's why I'm taking the difference between 9 and 2, then 2 and 7, 7 and 3, 3 and 1. Is this clear? Is the question clear to everybody? Any doubts in the question? Okay, good. Good. I can see your thumbs up. I'll give you a few minutes. Can you try writing this program and then we'll discuss the code together. Okay. So person who asked about assignment, I said this at length at the beginning. I do not conduct or I do not prepare the assignment. I do not correct the assignment. I am just here to solve your doubts and solve these questions with you. So I am really not the correct person to ask about this. What I would suggest is that you either mail the NPTEL team or you have this Google group discussion forum. Try putting your issue here. Okay. Because I am not involved in the correction or exam or assignment or anything like that. I am an external person who's here to solve these problems with you and clear your doubts. So I'm happy to clear any conceptual doubts you have, but these logistical issues, because I am not involved, I don't want to give any wrong information. Okay. And I think the instructions are given. You can check with your friends here. If anyone else has faced a similar problem, then yeah, if anyone else has a similar problem, then you can try to help this person out if you have faced the same problem during assignment. So yeah, please try the program. I'll give you 5 minutes, 5, 10 minutes. Please try writing the program. If you don't have your laptop with you, again, please join these sessions on a laptop if possible, or somewhere where you can code. If you don't have Python with you right now, at least try to get the logic of the program with you. Okay. But yeah, again, there are two parts to programming. There's getting the logic and there's syntax. Both are equally important. So the only way to learn Python is to do programs. So please try to sincerely do these things. What is the question? I didn't understand. You teach, is it a question? You teach only Python? Yeah, what else am I supposed to teach? I didn't understand. I hope you guys are trying out the program. Please try it out yourself. That will help. Okay, like that. I am teaching this I am a TA for this course. So I will be teaching whatever is in this course is a Python course. So I'll be teaching only Python. Also, I don't know Java to teach it. So I don't think I'll be teaching Java anytime soon. But I'm sure you can find enough NPTEL material and other people who will teach Java or whatever other language you want to learn. Again, remember that programming is about logic. Then the rest of it is the language syntax you will be able to pick up once you know. Cool. So, how many of you are trying the program? Just raise your hands. Okay, good. I can see a few hands are raised. Okay, yeah. Good. I'll give you 5 minutes more and we can discuss after. I'll give you some time, whatever. Others also please try out if you can. If you don't have access to Python, at least try to get the logic of how you will do such a program. So, has anyone got the solution for this program? Okay, I can see some discussion is going on regarding the assignment. Cool. I hope that person's request is done. Other than that, anyone who's got the program that we are discussing? Okay, maybe I will. Are you guys still working it out? Maybe I'll discuss the solution. Has anyone got the solution? Before I discuss, was anyone able to get the logic or the solution? Yeah, I will explain, but before that. Okay, no problem. As long as you've tried, that's good. Like, please try, just don't wait for me to give the solution. Okay, that's all I'm asking. So I'll discuss the solution with you now. Let me just close all this. Okay. Okay. So no one got it as far as I understood. So let's look at the question again. Basically, I'm getting a list. I have to calculate the difference between the neighboring elements or the adjacent elements, right? So as I said, 9 minus 2, 7 minus 2, 7 minus 3, etc. So I'm basically calculating. Is there anything in the chat? No. Basically calculating the difference between pairs of elements. And then this difference should be strictly decreasing. Sorry, not increasing, strictly decreasing. Okay, and then only I'm going to call it a condition is satisfied or not. So let's see. Here we have two ways of doing this. This is using recursive function, and this is using a iterative process. So here this is actually okay. I should have mentioned. Okay, so you can see here that in the recursive case, basically what I'm doing is if the length is less than 3, then it's automatically true. Why is that? Can anyone tell me that? In both of the cases, I have this condition. If length of L is less than 3, then it is true. Why is that? So do you see that, okay, I've written, we have the solution in two ways. One is using recursion and one is without using any recursion, okay? But in both of the cases, I have first itself, I have this condition that if the length of the list is less than 3, then return true for the program. Can anyone explain why it should? Yes, yes, please
Because we
go ahead.
must we just
Okay, it's breaking for me. Maybe my internet issue. Can you write it in the chat? Whoever was answering, please write it in the chat. Because it has only two elements. It has two elements or one element, anything, right? But basically, if I have only two elements, then it's automatically satisfied because there's only one difference, right? So there must be two differences or three differences, then only I will have. So automatically it's satisfied. It's true anyway, right? Obviously, it's decreasing. You can think of it like that. So this less than 3 also becomes the base case for my recursion. Okay. So here what I'm saying is I'm just checking this condition. If absolute value, this is absolute value, which gives you the absolute value of a thing. You know, right? If 3 minus 7, the absolute value is 4. Because here they told you that the absolute difference, like the order doesn't matter, it's just the difference which matters. So the absolute value of L of 1 minus 0 is greater than L of 2 minus 1 or whatever it is. So basically, in this case, what we're doing is because we're doing recursion, we are just checking for the first three elements. We are removing each element and then we are checking for this condition over and over again until we reach less than three elements. Okay, so that's what this is doing. So as long as the list is smaller, and it keeps on going, you will keep recursively calculating it, and finally if you get through all these conditions and it's still there, then finally it will give you true. Okay, so let me try to explain this again. So as I said before, recursion means to calculate n factorial, I have to first calculate n minus 1 factorial. The same idea is here. To calculate if this condition is true for n number of numbers, first I'm checking with removing the first element of the list and checking for n minus 1 list. Then I'm checking for the n minus 2 list. Then I'm checking for n minus 3 list until I reach less than 3, until I have only two elements, in which case it's anyway true. If at any point this condition is false, that the elements are not strictly decreasing. The difference between the elements is not strictly decreasing. This will give me false, and false and whatever will give me false. So it will break and give me false. And not break, it will return false. Okay? Even if this is true, this will give me false. So we saw last week false and true or false and false both give false. Okay. So this is how to do it in a recursive way. This is a little confusing, maybe if you don't understand recursion very well. If you find this
Ma'am,
confusing,
ma'am, I
yes,
have a small doubt.
yeah.
Here in the first line, if ln, if the length of the string is like 5, then how will we use, if it's, you say, it's here it's written that the length of the string should be less than 3, right? If the
No,
string is 5, then how will it work?
it's not written that it should be less than 3. Written that if it's less than 3, the condition is automatically satisfied. If it's less than 3, return true. Otherwise, it has to do all this calculation.
Oh, okay, fine.
Got it? So even in
Yes, ma'am.
recursion, I need a base case, right? So it will keep contracting and it will keep taking smaller and smaller element of, smaller and smaller element, I should not say, smaller and smaller part of the list until we reach less than 3. That's the idea. So this is recursive. If you, again, I'm telling all of you, if you find any program confusing, one thing is you can try printing things. Other thing is try writing it down. Like iteration 1, this happens. Iteration 2, this happens. That really helps. Write down in piece of pen and paper and work it out. Okay. So it's a recursive way. You don't have to do use recursion in this question, it's not asked. So you can also do it in a normal, iterative way. Iterative means just going through a loop, right? So again, the same idea is there that if the list that you're passing has less than 3 elements, it's automatically true. Okay. Now, if that is not the case, then for I in range length of L minus 2, so from L it's going till the last 2 elements. I mean, what is it? Not the last two, the second last element, I guess. So then you're taking the difference between I plus 1 and I plus 1 and I plus 1 and I will be like this and this. Then you're taking I plus 2 and I plus 1, which will be the next two, and you're checking if they are strictly decreasing. If at any point this condition is not satisfied, then it returns false. If it goes through this entire thing and doesn't return false, then it's true. Okay, so this is just simply a matter of use. Here what you have to be careful about is your indexes. Okay, your indices, your indices of your list and your array, you have to consider carefully and you have to check it like that. Okay, why should this be minus 2? Does anyone know? Why can't I just use L, length of L? Why length of L minus 2? Can anyone tell me why?
Uh, Ma'am,
Yes.
I think index will be out of range.
Exactly, because if I give a length of L and then I try to take L of I plus 1, then L is already, index is already the last element. There is no I plus 1, I plus 2, right? So that's why. If you want to keep it as length of L, then you have to do it as I minus 1, I minus 2. Then the opposite problem happens. Then I shouldn't start with the first element. I should start with the L is equal to 2, I is equal to 2 element. Okay. So this is what I mean by saying this program is quite simple in the sense that we just have to compare, we just have one condition to compare. But you have, because we are dealing with list, we have to be careful about the index that we are using. Okay. So that is where mistakes can happen. Is this clear to everybody? So let's try running the program and we can see what happens. Let me just clear this. So let's run the program. Let's use the example they gave itself. So it's like, sorry, 92731. So 92731. Can see that the condition is true. And this is 2 times coming because once I calculated using the iterative case and once with the recursive case. As you can see, the answer is the same. It's just a matter of, again, as I said, you can always be very creative with how you write a program. Let's try giving the other case, which is 10741. You can see that both of the pro function gives false as we know. Okay, is this clear to everybody? So let's as I said, let's try to do one more program. I had 3 programs today, but let's go try to do one more program. I think Yeah, this program you can see, I will share the program with you. If you have any doubts, by the way, in any of the questions, not about assignment, quiz, exam, these kinds of things, because I don't deal with that. But if you have conceptual questions, please feel free to mail me throughout the week. As I said, if you mail me early in the week, I can also put in slides regarding your exact doubt and we can discuss it in the class. So, yeah, let's try to do this program now, or maybe this is similar to the previous program. Let's try to do this program because this is a metrics program. So the second program you guys try on your own. I will share the program with you, the solution. If you have any doubts, you can tell me. Let's try to do this metrics program because matrices we have not done yet. Okay. So this is the question. A square n by n matrix of integers can be written in Python as a list with n elements where each element is in turn a list of n integers. So here we have a list where each element of the list itself is a list. Okay. So for instance, the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9 could be represented as, you can see that this is a list of 3 elements. Each of the elements in the list itself is a list. Okay, so this is what a matrix is. I think those of you, I mean, you should have covered matrices in your 12th standard mathematics. So I think you guys know what matrices are. Collection of numbers like this. You have to write a function called left rotate of m, which takes a list representation m of a square matrix as input and returns the matrix obtained by rotating the original matrix counterclockwise by 90 degrees. Okay. For instance, if we rotate the matrix above, you get this. So what you're doing is you're rotating it anti-clockwise or counterclockwise by 90 degree. So imagine taking this 1, 2, 3, 4, 5, 6, 7, 8, 9 and rotating it like this. Okay. If you can see my screen, you're rotating it by one turn like this, in which case this 369 will come up, 258 will be the next, and 147 will come. Your function should not modify the actual argument which you are providing. Okay, so basically 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm rotating, I'm doing one left turn. So, like how you used to do in your assemblies in school, you're just doing a left turn. When you do a left turn, then with in the counterclockwise rotation, basically you're doing a counterclockwise rotation by 90 degrees. So it's 369, 258, 147. Is there any questions? Any doubts? I don't think there's a week 3 quiz. I didn't see one in the course page. But again, you can ask the TAs. I mean the other TAs if this is a thing. Yeah, I just solved those questions because I think those kinds of questions are important for understanding your conceptual understanding also. Anyway, this did anyone everyone understand this question? Is there any doubts in the problem statement itself? Okay, I guess not. So please try this program. I'll give you 5, 6, I mean, we have 10 minutes till the end of the class. Please try it and then I'll give you 5 minutes and maybe we can discuss the solution and then we can end the class. Okay. So yeah, I'm giving you some time. Please try doing it. And here you have to be, little careful about how you're going to take a matrix elements, right? Because you have a list within a list. You just don't have a single list. Each element of the list itself is a list. Okay. So keep that in mind. Are you guys trying? How many of you are trying the program? Okay, good. Good. Keep trying. I'll give you a few more minutes and then we can discuss the solution. Good. Those of you are trying very good. Okay, since there is only 5 minutes left in the class, I'll give the solution. Those of you are trying, please keep trying. And as I said, even after, keep trying. Try to always, whenever you encounter a program, try to understand the logic and write it yourself instead of just looking at it. Okay, that's how you learn programming. So let me skip. So I am not discussing program 2 as I said. It's something quite similar to program 1, but please try it yourself. I will anyway share the Python files with you. So let's go to this program now. Program 3. Okay. So this is the function f what is it? Or left rotate of m. Okay, so this is just how you input the matrix. You can see that you have n. Here I'm considering it to be a square matrix, so there are n rows and n columns, and you can see that for every row you have to, I mean, for every element of the matrix you essentially have another list. Every element of the list is another list, right? That's how you think about it. So now you can see that when I'm trying to rotate m, what I actually do is I'm defining a new matrix m, and then basically this is basically gives you the rotation part, because this is basically the row. Okay, so when I write a of m of n, a of m gives you the first row, a of 0 gives you the first row, a of 1 gives you the second row, a of 3 gives you the third row, right? Or whatever it is. So here you can see, for example, 1 2 3 is the first row, so that is basically your list of 0th element of your list. 4 5 6 is your second row, which is the first element, uh, second element of your list with index 1, so on. So a of x gives you the first row, whereas a of all the elements in the first, the second index tells you about the columns basically. So here basically what you're doing is, you can see that you have a range of size -1 -1 -1. So here you're basically going from the reverse order, and you are appending m of r of c in the position like this. So here, for example, 3 has to go here, right? 2 has to go here, 1 has to go here. So basically what you have to do is, even though it says you're flipping, you're essentially, you are reversing the list, right? You're reversing the row, and then you're putting it in the column. So 1 2 3, you're taking it as 3 2 1 and putting it in the column. So if you see it like that, that's exactly what's being done here. So m of r of c is being put in the c plus 1 size minus c plus 1 column. Okay, so this is the idea. So again, try writing this down. It's kind of difficult to explain it verbally, but essentially what you do is that, think of it like this: 1 2 3 has to go in this first column. Instead of going in the first row, it has to go in the first column and in the reverse order. So that's why you're going from size -1 -1 -1. That gives you the negative or the reverse way of calling the list. Okay, so try writing this down. I think it's not difficult, but it's difficult to explain it verbally. So I'll just show you how it looks when I run it. So let's see a 3 by 3 matrix. Let's enter the same matrix that we saw. So you can see that the answer is 369258147, and I also printed it in a matrix form. Okay, so yeah, that's it for today's class. As I said, I don't want to keep you guys. It's 4:58, so we can end on time. Essentially, yeah, I'll share with you all the. Okay, thank you. Thank you about for the compliment on the teaching. Are you sharing the programs in the WhatsApp group? As far as I know, there is no WhatsApp group. The programs are being shared in a Google Drive. Okay, the links are being made available. So let me just do that, the final bookkeeping. So as I say at the beginning of every class, this is my website. Just go to this website, you'll find all the links that you require. Okay, so let's see here. This is my website. If you go to my website, here is the YouTube playlist with the recordings. Here is the Google Drive. In the Google Drive, if you click here, you can see all the Python programs and you can see the slides. Okay. So I don't think there is any issue there. Please, like every class, every 20 minutes, people ask this. So don't worry, I'm making the programs and slides for you. It will reach you eventually. The NPTEL team also shares the links with you. I think you will be getting something like this, right? So here also the YouTube links are being uploaded. So you can, I think this sheet is being shared with you. So you can also go here and the other people's lectures also you can find. Okay. So yeah, just bookmark this. I would say I made this page for this reason. Just links are all in one place. Okay. Okay, yeah. I mean, I explained it at the beginning of the thing, but yeah, now you know you can share it. Okay. You can save the bookmark thing. Okay. Cool. So yeah, next week we will have class on next week also, maybe not on Saturday. I have to see. I will let you know guys know about the thing. But yeah, thanks for joining on Sunday and I hope you have nice rest of the day. Thanks a lot for joining. I'm ending the meeting here. Okay. Bye everyone.